Hey, hello everyone who's tuning in. As we all know, we're living in extraordinary times with Corona going all around, so people are working from home. Decided to do a meetup online this time and see how it works. Hey, hello everyone who's tuning in. As we all know, we're living in extraordinary times with YouTube. Corona going all around, working to do a meetup. All right, I apologize for that. Something went wrong with the feedback loop from another tab. So yeah, welcome again to this meetup. I will put other participants on the stage. So there's Dexter and Sarah.
Hey.
Well, we're still waiting for things. Yeah. So yeah, great to so yeah, welcome again to this meetup. I will.
Can't really hear you properly.
All right. So yeah, for the echo. So let's try to get this in order. So Sarah will start the meetup with her presentation. Are you ready to take it away?
Yes, I can go right now.
All right. Yeah, I will enjoy.
So I'm sharing my screen. Is it being broadcast as well? Yes, awesome. All right, let's get started. So today we're gonna talk about why JavaScript numbers are weird and how to fix it. So beforehand, please let me know if my stream is cutting because the internet is being a little bit crazy here. All right, shall we? So my name is Sarah. I work at Algolia and I love numbers. I love them so much that 2 years ago, I started working on Dinero.js. And so Dinero.js is my biggest open source project to this day. It's a library that handles money in JavaScript. It's a little bit like Moment, but for money. And when you start dealing with money, you need to understand a huge deal about numbers. But the thing is, I was never great at math. In high school, I actually majored in English literature. I also never received formal computer science education. So I came into this whole number mess with pretty much no equipment. But the thing is, I quickly realized that I was not alone. So today, I want to go on a journey of understanding JavaScript numbers. This subject has been talked about brilliantly and exhaustively many times. However, what I want to do is I want to help those of you who feel like every time you watch those presentations and you read those articles, at some point it comes to a turning point and you're like, I'm lost, I'm bailing here. And so we won't cover everything. We'll have to discard some cases, some exceptions. But what I want to do is my very best so you get out of this session feeling like you finally get it and you're ready to dive deeper if you want to. All right, let's go. So we use a decimal system to count most things. It's everywhere, in measurements, if you're using the metric system, in weights, in money, etc. So a decimal system is a system that uses a base 10. What does that mean? In the Arabic numerals that we use every day, we have 10 digits to represent numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each digit represents a power of 10. Each digit that you see on the left is 10 times superior to the digit on its right. 345 is equal to 300 plus 40 plus 5. Or 3 times 100 plus 4 times 10 plus 5 times 1. Or 3 times 10 to the power of 2 plus 4 times 10 to the power of 1 plus 5 times 10 to the power of 0. So far, so good. But computers don't count in decimal. They count in binary. Instead of counting in base 10, they count in base 2. They still, however, have to represent our decimal system. Because when you buy online, for example, you don't expect to see prices in binary representation. That would actually be really weird. So computers must convert decimal to binary and vice versa. When they receive a decimal input, they need to interpret it, they need to convert it and store it in a binary representation. And when they return it, they do it in reverse. And most of the time, this is fine. All right? Base 10 integers can easily convert to base 2 because any number to the power of 0 is equal to 1. And you will see a bit later why this is important. Let's try to convert 5, a base 10 integer, to binary. So the highest power of 2 in 5 is 2 to the power of 2, which is 4. We have it one time, so we can write 1. Then we remove 4 from 5, and we have 1 left. And so from there, we can go down to the smallest power of 2 available. 2 to the power of 1 equals 2, right? We have it 0 time in the remainder, 1. So we write 0 down, and we move on. And finally, 2 to the power of 0 equals 1. So we have it 1 time in the remainder, 1. So we write 1 down. And 1 minus 1 equals 0. So we're finished. 5 in binary is 101, or 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. 4 plus 0 plus 1. So computers can easily go back and forth between both. But now, what does this look like with fractional values? Introducing the double precision floating point format. So that's a mouthful. And you may also have heard it as the 64-bit floating point, or simply put, floating point arithmetic. And it's a format that was standardized in 1985 by the Institute of Electrical and Electronics Engineers, and that modern computers support to represent real numbers. This includes integers and decimal numbers, or floats, if you've heard of them like that. And it is this format and this format alone that is responsible for the inaccuracies and limitations that you're used to, right? So this is not JavaScript. Many languages have the same limitation. So you can tell that to your smartass friends who are always making fun of JavaScript, right? You can tell them, hey, you know what? This is not only JavaScript, and I know it for a fact because I've seen a presentation about that. So the thing is that many languages have alternatives. They have dedicated types. They have modules specifically to handle that. For example, if you do Java, you have a built-in support for arbitrary precision numbers with a class called Big Decimal. And before ES 2020, JavaScript only had the number type to represent numeric values. They're expressed in the double precision floating point format that we just saw. And this means that when you store a number in JavaScript, you get 64 bits equals to 8 bytes in memory to represent it in binary, right? So here is the representation of your available 64 bits and how the computer uses them to store your number. So don't freak out. We're going to break it down. We're going to see exactly what it does. So first thing, you have the sign, and the sign represents whether the number is negative or positive. 1 when negative, 0 when positive. Simple. You have the fraction. The fraction is also called sometimes the significand or the mantissa. And this is where you store the binary digits that represent the number. They can be integers, they can be decimal. And when I say decimal, I mean fractional. And they all go there in those 52 bits. So note that any value that goes there always starts with 1 because we're in binary. So that 1, that first value 1 is already encoded in a 53rd hidden bit that you don't see and that can change. So this is why you can see that you have 52, exponent is 11, and the sign is 1. You also have to go to 64, 1 bit that is already assigned that you cannot see, you cannot change. And so the exponent, the final part, indicates the point, so floating point, where the point should go. As we're storing numbers in binary and we're collocating the integral and the fractional part, we need to know where the separation happens so we can convert it back and forth. Sorry for the noise. All right, let's move on. So this is how we are able to know where the point is, right? So here we're going to store a value in binary that is going to allow us to scale the value that we have in the fraction part, in the mantissa. All right, so enough craziness. Let's go with examples. All right, so let's store 5. We converted it earlier. So if you remember, this is 101 in binary. What does happen when we want to store it into that grid that I showed you earlier? So here, how it is stored in our 53 fraction bits. So as you can see, the first hidden bit is always 1. So we don't need to assign it ourselves. It's already here in gray. And note that the point, we have a point at the end of the sequence, and it's indicating how to interpret the value in positional notation. So we'll talk about it a bit more after that. Now let's try storing 0.75. Right? So first, we need to convert it in binary. So there is an easy technique with decimal values like that, with fractional values. When you want to turn it into binary, is that you will keep on multiplying it by 2. So the integral part of the results before the point is the binary value that we will write down, and then we will multiply the fractional part, right, until we have nothing left to multiply. So 0.75 times 2 equals 1.5. We write down 1, the integral part, and we move on with 0.5. 0.5 times 2 equals 1. So we write down 1 again, and we're done. We have no fractional remainder, so we're finished. So 0.75 in binary is therefore 0.11. 0 integral parts, 11 in fractional binary. What does that look like when we put it in a grid? It's simple. We have 1 and 1 stored in our 53 fraction bits. And note that the point has moved, it has floated. And again, it's indicating how to read and how to interpret the value. So far, so good? Okay, I'll move on. All right, so what do you expect that 5.75 is going to look like in floating point math? Any guess? So I want to see some things in the chat. Try to guess what it will look like. Anybody? Nobody? All right, that's okay, I'll move on. So 5.75 in the grid will look like this. There we go, 10145. All right, and 11 or 11 for 0.75. And the point that indicates us where the split happens. So that's perfectly logical so far. And here's what it's looked like in the entire grid. If you show everything, we have the full representation. 0 for the sign, it's a positive number. 10111 for the fraction, and here the first one is hidden, right? And then we have 1 for the exponent, which is the value that allows us to place the point, to know where the point is. And so the point, as we saw, floats. It moves as we change the value, adapting to how many binary digits we need to represent our base 10 values. So, okay, but what was this craziness? Like, okay, I tried adding 0.1 plus 0.2 and I get this crazy value. Why? Why the hell? Like, do you even math JavaScript? Again, that's not JavaScript. That's actually floating point math. Some base 10 fractional values cannot be properly represented in binary. If you try converting 0.1 in binary with the technique we used earlier, you will quickly exceed the 53 bits limits. Same with 0.2. You will see, try to do it at home. You will see that you will end up writing endless sequences of 1, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0. And before you can even realize it, you will be way off the 53 bits limits. So the extra digits here are assumed to be 0 and they're discarded. There's no more room left, basically. Therefore, an imprecise value is stored. You input 0.1, but actually what's stored in memory by your computer, what it's converted to, is imprecise. It does not exactly and accurately represent what you have in mind. So when you execute this expression here, the computer imprecisely stores 0.1 and 0.2 in binary with the available bits at its disposal. It then adds up those two imprecise values. And finally, it reconverts that result in decimal and it returns it to you. That's why you're getting messed up results. You're adding two things that you think are a given value, but actually that's not the case. And what the computer is doing is trying its best to represent it, and it's adding two imprecise values together, and it returns a converted value back that is close enough, but not quite. And when you understand that limitation, you quickly realize that it creates problems with integers as well. We saw earlier that integers can always technically be represented accurately, right? But the problem is it doesn't only lie in the representable precision. It is about the representable range, the space that you have. The constructor number in JavaScript exposes a static property called max safe integer and another one called min safe integer, by the way. It returns quite a large value. If you do that in your runtime, you will see you will get the same result. And when you try to do math with it, so here, for example, I'm trying to add up 2 to it, it starts behaving oddly. So why would it do that? Like, we're supposed to have precise integers, so why do we see that craziness? Well, it's actually pretty simple. It's the same problem as that you have with decimals. These values here are the highest and the lowest integers that you can represent in double precision floating point format, every language. Any value higher or lower than these two would require more bits for accurate representation. And to see what it means, let's look at how they look like in the grid. First, you have the max safe integer, and bottom second, you have the min safe integer. And as you can see, they're the same. The only thing that changes is the sign. So it's pretty easy to understand. And you see that the point is at the end, which shows, like, it floats at the very end, which shows that we don't have fractional values, that we are operating with integers. But here you can see that they suffer from the same issues that we have with fractional representation. Lack of space, and it results in inaccurate conversions. So if you try, so here, if you store it as is, it's cool. But then if you try to respectively add or subtract, you will overflow and the format will discard all the extra digits. All right, so legitimate question at this point. What do I do? How do I operate? So there are several ways. First, try to always avoid calculations with decimal values. Instead, use integers and divide the result by 10 to the power of the required precision. So for example, if you need one decimal place, 01 plus 02, which is one decimal place, divide by 10 to the power of 1, which is in that case what we're doing. And that's exactly what I do in Dinero.js. Amounts must be input in subunit formats. So for example, with dollars, you enter 500 cents, and it is to represent $5. And this way, all the calculations happen between integers. And the base to the power of the currency's exponent, so 2 in dollars, is only used when I need to return the formatted value. Second, if you can't support it, you can use big integers. So if you're not familiar with big integers, they're a new JavaScript primitive type which lets you represent arbitrary precision integers. And they look a lot like regular numbers, and you can recognize them in the literal form with the n at the end, as you can see here with 10n. And they use the same mathematical operators as numbers. So here you can see we have our MaxSafe integer in big int format, and we added +2n, and we have a result in big integer, which is this time accurate. There are some drawbacks with big ints. For example, first, they cannot represent decimal values. They're big integers. They're also not compatible with numbers. You cannot mix big integers and numbers. And also, another thing is that they cannot be used with the JavaScript object math. So you cannot do math.square root with big ints. That's not, it doesn't work. Another thing to know about that is that there is a performance gap between big ints and numbers. Arbitrary precision math is slower than floating point math. The double precision floating point format is fast at the cost of precision. So you need to choose wisely. Don't over-rely on big ints if you don't actually need them. Don't, just because you're afraid that you might lose precision, just go directly to big ints if you don't actually need that. There might be better solutions, and you may not have that big of numbers anyway. So don't just go for it. It's not a silver bullet. It's a tool to fix a specific problem. And secondly, even though your browser probably already implements it because you're probably using an evergreen browser that is updated to the latest version, it is still a very new thing. It's a new type, and not every environment supports it. So if you need them, make sure you have a fallback for users who are using older environments. For example, there are really good libraries like Big.js. Big.js is really a great option, which I believe uses strings under the hood. So you still have the performance drawback, but you have something that browsers. And so, for example, in the next version of Dinero.js, the major version, you will be able to use anything Big.js, a decimal, numbers, big ints, whatever you want, by implementing a calculator yourself. So this is all good, but this is only scratching the surface of floating point arithmetic. But I really hope that this gives you a good idea of how the whole system works and why it does what it does, because that was really like what I really wanted to do, is give you insight in a clear way that makes you want to go a bit deeper. And you can go much more in depth. You can discover really funky edge cases and exceptions by visiting the 3 following websites. There are more, but those 3 are my favorites. The first one is an exceptional resource. It gives you a visual representation of your base 10 numbers in the 64-bit format. This is what I used in the presentation to show you the grid. And the author of that website, so his name is Bartek Czopka, I hope I say it right. He did a brilliant talk on it at JSConf EU 2013. It goes really, really deep. So if you're a nerd, go for it. I really highly recommend it. And yeah, especially if, like me, you want to spend afternoons writing a bunch of zeros and ones on a notebook, and you want to convert values back and forth and do mind-boggling binary calculations. I definitely swear to you, it sounds scary, but it is mostly fun. Thank you. And if you have questions, go ahead.
Oh, thank you, Sarah. It was amazing, deep technical talk. I wrote in the chat that people can ask you questions, but I don't see anyone asking yet. Maybe let's wait a couple more seconds. If nobody asks, then we can save it later. And otherwise, let's give a screen to Dexter. So,
hello.
Dexter.
Oh, let's get this one. Hi. Yeah. So I'm Dexter, and I have a love for Svelte, which is a really nice framework. I hope you've heard of it and played with it. So today I'm gonna do some live coding, and recently I've taken up a hobby of making visuals. So these are a bunch of examples of stuff I made. They're all fairly simple. Most of them are like 40 lines of code. And today I'll make some code. Usually it's a free-flowing thing. So yeah, this is the setup of a Svelte app. This is the index.js file, and you import a Svelte component, and you bootstrap it, like target, mount it on a target document. And this is the Svelte component, which is rendering these things. You can visit my code sandbox on this bit.ly URL, or this URL is also not too hard to read, I presume. Yeah, so let's get started. So I created this SVG component. Let's import it. So I can write a script tag, and I can import this SVG component from this this local. Oh, not SVG. It's a Svelte file. I just have to import it. I can use it, and there we go. It draws a circle. So most of my visuals are based on circles. So that's how I make them. So instead of making a circle using just a plain SVG element, it's much more interesting to draw all the points making up a circle. So if I add more script here, I can say make a variable containing the amount of points. And let's say make 10 points at first. Then I can make a new variable containing the array with all the points. So I make a new array with the amount of points, and I map this to get the indexes of this. So now I have just a plain point, and I can map these indexes into some sine and cosine functions. Sine of I divided by the amount minus 2 times 2 times pi. And another one for the cosine. So now I have an array containing points, and I can use this points in a polyline. And I have this local variable point here, and I can pass it to my polyline with this shorthand. Normally I will write it out. You can write points or assign points as an attribute to this thing. And there we go. There's a small circle. A circle also has a size or a radius. And let's set the radius to 10 this time. Can I increase the fonts? I can. Can even. There we go. So let's increase the stroke width. So now I have a circle of a few points, And if I increase the points, it will get more round. But this is just fairly simple. So I usually add some aspect of time in my visuals to have some movement going. And I use request animation frame and this API of JavaScript. It's called the date API. And it gives me a date. And I can get the millisecond time out of this, like this. So now, for instance, I can multiply the radius times the sine of the time. It's the sine of the times. And if I import this utility function from Svelte, I get an onMount hook, basically, which I can pass a function, and this function is called onMount, and what this returns is the onDestroy function, basically. So let's say I have a function here which sets the new time. I can do it like this. And I create a request an animation frame with this new function called next, which I'll introduce here. So every tick or every next I call tick, and I update this request animation frame variable. And to start off, I call next, and to clear everything up, I call console animation frame with this anim. So now, and Code Sandbox has a weird bug, I think. Or am I doing something wrong? Going next, tick updates the time. Do I have to? Because this points variable is not being updated yet every time this time variable is just whenever the code changes, it will refresh and there's a new time. So Svelte has this reaction where with the label statement syntax, I can update this points variable whenever one of these dependent variables will change. And now it will go very quickly. It will turn very quickly, so I can divide the time by 100, still quite a lot, by 1000. Now it's visible. So, yes. Recently I've been drawing some more fancy patterns with spirographs, and a spirograph is consistent of a bunch of circles turning into each other. So let me make some variables which will determine the size of these circles. So every circle will, and there will be a variable of the difference, like a small value, so I can count. So instead of like drawing every point in one circle, I will now draw just a bunch of points. So this is the first circle. And basically every step along the way where it looks nice, it's cool. So you can maybe save that if you want, if you think it looks cool. And by accident you find a lot of nice features. So in a spirograph, like you have a circle and there's one circle moving inside the other circle, but the movement is based on the ratio, and this ratio is the outer circle divided by the inner circle, and then the inner circle will be the size of the outer circle. So I just have to really copy this, and there we go. It's a spiral. But if I draw more points, it will loop back onto itself. And now the interesting bits happen in between, where I can modify the size of one of the aspects by the time. Oh, by the sign of the time. So now it's sort of turning over one axis. It's a bit fast maybe. So instead of directly manipulating these variables, I can also manipulate. I do like this one though. Let's keep it. The size of the circles themselves. And this one is going quite a bit fast. And if you add a bunch of zeros, it will move slower. And I did notice, like refreshing Code Sandbox does give like a clean stack, and it makes it run faster. So now in 10 seconds. It will make pretty pictures. Decreasing the stroke width here, just to see more lines. Yeah, I think you can do with a bit slowness. This works. So instead of having this on mount ticker time thingy here, what I usually do is I use Svelte's store feature, where I can get create a readable store, for instance, for the time, which will just always have the current value, and it will be updated with the request animation frame. So I'll import the readable from the Svelte store, and instead of making this time variable tick itself, I will make it a readable store, which will be initialized with this millisecond time, but it will be updated on request animation frame. So basically it's the same structure as the amount. So it will get a function which sets the value, and it will return this this function will be called whenever a subscription is added. So basically a store is a subscription in Svelte, and instead of calling tick, it will call set with the new time, and remove this tick. And because the time is now a store, Svelte, I can call subscribe on this. Where I get like the new value t, and I can call it to console.log. Where it will log the time every time it will be updated. But what I will be doing is using the dollar variable, it will auto subscribe. There we go. So now time is stored, and I can even move this to a separate file. So let's do that. Just get this time and the readable. So now I can use the same request animation frame hook in different places. Let's call this time.js and import the time from this time.js file. There we go. I imported time. So a nice thing I found out is whenever I create or make this diff variable larger, it will be more movement in there. Even if I make it larger, there's a lot of cool stuff in there. But since it's multiplying quite a lot, I do have to increase the slowness of these moving sine functions. So I have to check it out. There we go. Let's refresh it for a smooth experience. I don't know how you will experience the smoothness. There you go. So this SVG Svelte is not very reusable. If I want to draw more stuff in the inside of the SVG, it's going to be a big file. So if I want to just move this polyline over to a new file, I will have to make a new file, and let's call this one spyro.svelte. and since this polyline is a SVG element, Svelte tells you to use this special Svelte options element to pass in the namespace of said element. So I can make SVG elements, and this will contain the script as well. So now I can move my points and basically everything here over to the Spyro file, and I just import. Oh, is this? And now I can just use my Spyro here. I have tried other JS frameworks. I've worked with React and Angular JS, and a bit with Vue. So I do have experience, and I professionally I work with lit elements, which is based on web components. Oh, I did. That's option. Oh, namespace. There we go. So now I have my component back. So yeah, Svelte allows me to make sort of these quick cut and paste options without having to worry too much about entangled designs, because in a sense it's just plain JavaScript. Inside of the script tag, your local scope will contain all kinds of local variables, and you can just use them like you would in a old style templating language. So another cool feature I would like to show, I'll make a new file. Let's call it rando, for making random dots. And let's immediately use it as well. but this file doesn't exist and not yet. So let me. Oh wait, it's the wrong. Be a bit patient. My computer is a bit struggling. So let's create this rendo.svelte. I can add the Svelte options namespace. Oh. And then draw a circle with a property CX and CY and a random or a radius. So let's say assign a random CX, and since it's like 10 to minus 10, and there's a CY and a radius R, which doesn't need to be that big, and instead of like not very visible, let's give it a fill. And let's assign it. There we go. But now I have to constantly change the file in order to update it, which doesn't really work. So let's import time again. And I can say every time this time variable is passes a second, for instance, I want this reaction to be called. So let's call these ticks, which will just be a variable being updated every second. So I just round it off and I divide the time, which is in milliseconds, by 1000. And whenever there is set ticks, this code inside of the brackets will run as a reaction. I can update basically these variables. So now every second it will tick, and apparently like the request animation frame. Oh, I defined them as constant. There you go. Something's not working. Ah, this is a store. So now every second it will update it, maybe do it 10 times a second. But now it's just all jumping everywhere. So a nice thing about Svelte is it has this built-in stores which allow for tween functions, which shows the power of using these stores for several variety of ways. So I can, from Svelte motion, I can import this tweened, and I can make these CX, CY, and R variables tweened, and they become a store. So I have to subscribe to them using the $sign, and I can also assign to them with the $sign. This would be the same as using cx.set with the new value. So now it's moving around, and if I make this fill like a white one, but not totally. Which is a bit too much. There we go. Let's add a bunch of these things. So I can make an array of 10 items. I don't really care about the iterator here. And I have 10 of these random moving things. I think a bit too fast. Let's change the timing. Well, there you go. This is a bit on how I make Svelte visualizations. So, are there any questions? I can continue though. Let's make a random view. Update the fill, so I can use the JavaScript notation and the HSL, which is not everywhere supported, but who cares? I'm just randomly generating these colors. This needs to be 50, I believe. This print I also have a delay, for instance, so I can, or a duration and a delay and all the other things. There's a bunch of options you can pass. This. There you go. So now I'm changing colors. Let's add 100, and I'd like this paragraph to be in front of everything. And if we move or increase the size, we don't have them all moving constantly through the middle. So yeah, you can go ham, and there's a lot of ways you can use this stuff. So I'm still experimenting with all the tools at my disposal. There's a big list of things I'd like to try. So yeah, Any questions? No questions?
Absolutely true. That's really mesmerizing animations. Yeah, there was a question, but I think you answered it in mid-talk about the other JS frameworks. I think you said you use Vue and Angular as well, right?
Ah, yes, yeah. So I have experience with React and Vue and AngularJS and before with Django type frameworks and like the more Python server-side rendered frameworks and PHP. But now for personal projects, I'm always using Svelte, unless I can't do otherwise. But prefer Svelte.
And there's another question just popping up now, where they can find presentations. I would say that this meetup
This one you can
will be
find.
in the video. And okay, you can also share your link, of course. But we're gonna put this video, of course, in Frontend Love channel, and in the video description, we're gonna add a link to the slides.
Yes. Yeah, I will post this link on the chat on YouTube. Cool. Thanks for having me.
Thanks, Dexter. All right. I will take it over with the next talk. So I've made a presentation about type coercion in JavaScript. I knew this meetup was being organized, and type coercion was a topic I really wanted to dive into a bit, and this was a good reason to look into it deeper and do some research. Let me put the slides on the max, so you can see the code examples better. And I will switch to other tab because I'm casting from my laptop. All right, so type coercion in JavaScript. By the way, I'm Harijs. I work for Passionate People. I'm doing a lot of front-end consulting. I work with JavaScript, TypeScript, most on the front end, so some back end. And today, I'm going to talk about type coercion. So what is coercion? It's an English word for forcing somebody or something to do something. So basically, to achieve something by force. And in programming context, it is applied when you force a variable of one type to become another type. And since JavaScript is a dynamically typed language, that can happen quite often in our code. So and that is partially responsible for this all madness that we experience and a lot of hate JavaScript gets. So in this talk, I will try to demystify a little bit of what is going wrong, what is going on, happening under the hood, so it will be a bit more clearer. And you probably have encountered these games online where it's like Minesweeper, where you have to guess if some of the values are equal or not when using the double equal operator, and partially that is also sometimes due to type coercion, because some operators force type coercion. For example, if you have a string on one side and number on the other side, then the string will be coerced to a number, and then the comparison will done, and the value will come out of that. Let me quickly switch back to the other tab to make sure everything's okay with the stream and my mic sound is good. All right, I think we can continue. So yeah, guys, if you have any questions, don't hesitate to ask them in the chat. I will try to answer them as I go or later. All right, so yeah, this is actually the answer sheet to the previous game, and we will discover some of the concepts and reasons in the further slides. So first of all, there are two types of coercion that can happen in JavaScript. One is explicit, and the other one is implicit. So explicit is when you are purposefully trying to cast one type to another type. Let's say you have a string of numbers and you want to cast it to a number. That's explicit casting. Implicit, it's when you don't necessarily try to do it, but it happens anyways because of how the language is built. And coercion happens to 3 target types. So 3 basic primitives. It can happen to string, to number, or to a Boolean. And let's look into explicit coercion a little bit deeper. It's also called typecasting. So coercion and typecasting is practically the same thing, it's just a way to name them differently. So explicit conversion is very, very simple. When you have a number and you wrap it in a string constructor, you get it out as a string. When you have a string and you cast to a number, you get a number. And when you try to cast something to a Boolean, you get out a Boolean. You can do that. In practice, of course, we do some other things. We parse int, or we wrap, do a plus sign to a number in a string, then we get the number as a string, and that actually is implicit coercion. When you coerce an object to a string, you get a string saying that's an object. When you try to coerce a number, empty array to a number, you get a 0, and that's one of the JavaScript I will not say perks, but yeah, one of the interesting features that makes a lot of people sort of pull out their hair and see the inconsistencies it has, and that's why the JavaScript gets a lot of hate. And similarly, you can cast any object value to a Boolean, and then you will get Boolean out. Another thing you could do is, of course, you can also cast a date to any of these primitive values. So if you cast a date to a string, you get all this description of long date. You would cast a date to a number, you would actually get the Unix time string, which is simply the number of seconds since the Unix era. It's the 1st of January to 1970. And date cast to Boolean would be simply true. Now, I'm not sure if many of that know, but probably plenty of people do. You can actually, when you're implementing your own classes, you can provide methods which JavaScript engine uses under the hood to perform these conversions. Because if you would look at array or object prototype, or even a number or string prototype, you would see that they have these methods. They are implemented, of course, in native code, so you cannot see in console what are the logic inside them, but nevertheless they are there. However, if you build your own class, you can actually implement your own logic. So if you would need, for every reason, to serialize your class, you can implement the string method. And of course, here I'm simplifying it greatly and just returning constant string and number. But in reality, you can have your own logic here that makes your class object to convert with some very specific logic. And of course, sorry, I switched to the wrong button. So yeah, and of course, when you would try to typecast your object to a string, it would convert to whatever you're returning from this method. Same thing with a number. However, for the Boolean, the case is that all objects are true. With the Boolean, it's actually very sort of simplified kind of, because everything is true except the number of falsy values we know. Of course, that's empty string, a 0, null, undefined, nan, and I think a couple of others. So before we continue to the next slide, let me switch tab to check if everything's going well with the stream. So no questions so far. So yeah, I'll continue then. And that brings us to implicit coercion, which is number one reason what makes JavaScript seem so inconsistent and bizarre language, and also get a lot of hate in developer community, especially from people coming from hardly typed and more consistent languages, which all of them also have their own weirdnesses here or there. But yeah, JavaScript gets a lot of hate, and rightfully so, maybe, because yeah, implicit type coercion is very erratic, and you really have to try to dive into it to figure out what's happening under the hood. Okay. With implicit coercion, of course, there are benefits and some some profound drawbacks, but we have to put everything into context. The JavaScript eventually was designed in 10 days, right? It was 95. So I don't know who in their right mind can expect something profoundly consistent and great come out in 10 days. JavaScript was intended to be as a scripting language in the browser, and it's amazing that it's gotten so far, and yeah, since ever then. But we have to all remember that when it was designed, the purpose was it to be very simple, easy to use, easy for beginners, because JavaScript was something that would come with your HTML or in a JavaScript script file, and browsers needed to make sense of it, and almost everyone should be able to write it, because internet has always been meant to be inclusive, and JavaScript was meant to be accessible. So you didn't need to have computer science background necessarily to do something in it. If you want to access a DOM element and make something move or appear or disappear, you shouldn't need a CS degree and full-blown developer sort of background. So that's why a lot of conveniences were sort of chosen in design of JavaScript, and one of them is type coercion and easily converting one type to another in various conditions. So what we as a benefit, we're getting a shorter and more readable code, and we don't need to write that much code and that much error handling, and sort of proceed with happy flow mainly, because you write something and a browser will figure it out what you meant. However, since JavaScript has evolved to be such a fundamental language of the web, and not only, of course, it's being used on the back end, and almost every device nowadays can run JavaScript. So it also is a big source of bugs and frustrations because of this implicit type coercion. Okay. So yeah, this is since JavaScript is dynamically or weakly typed language, conversion between the types happen often automatically under the hood when you actually don't maybe explicitly intend it. JavaScript does it anyways to perform its routine. And implicit type coercion is triggered whenever you're applying operators to the values of different types. Let's say you're doing something when you have a string and a number. Let's say you're adding them, dividing them, or comparing them. If those are different types, then JavaScript will perform type coercion under the hood to make sure what will be the outcome of that operation. So we'll follow up now with some examples, and these are just a few ones. So something is happening here, of course, in the first line when you're comparing 8 to undefined, and it's returning true. So something has to happen. Sorry, it's returning false. Something must happen here when you are dividing 18 by a string of 3. Clearly, since the result is 6, that means that JavaScript under the hood converts the string to a number. However, if the string was not easily parsable to a number, the outcome would be this would be not a number, and of course the operation would also be not a number. Something very bizarre is happening here when you adding a new date with undefined. A date becomes a string, and undefined is also becoming a string, and then eventually you put the two strings together, and you get one big string where everything is combined. Very bizarre. You wouldn't expect that, right? And on the other hand, yeah, who would in their right of mind would add date and undefined? So yeah, don't do that in production. These are bizarre examples. I'm just trying to shed a light on what's happening under the hood, and we will go in those examples a bit more deeper in following slides. So what's happening when you're trying to add undefined and null? Weirdly enough, it's not a number. Yeah, of course, undefined and null both are not a number. So the result is valid, but still not really expected. Would you expect that that gives you a none? I certainly wouldn't. The next one is maybe more understandable. When you try to multiply new date by 2, you see this great number coming out. I think clearly what's happening under the hood is the date being converted to the, sorry, I'm going too fast. Date is being converted to a number of Unix time, and that Unix time is getting multiplied by 2, and you're getting that. And another example is that whenever you're wrapping whatever expression it is, whatever variable or expression in parentheses inside if statement, that expression gets coerced into a Boolean. Otherwise, the engine cannot proceed to figure out if that clause should be executed or not. I see there's a comment from Dexter. Very nice. So yeah, these are the, I guess, maybe quite well known, but hard to memorize, and nor you should memorize examples. What happens when you try to coerce some value in the if statement? But let's look at implicit conversions to string more deeply. So conversion to a string is triggered every time you're using plus operator when you're trying to add 2 values, and when one value is a string. So only then when at least one value is a string when you're trying to add them. So in this sense, when you add an empty string to 2, you get a string of 2. When you add empty string to Boolean true, you get a string saying true. So true gets cast to a string. Same happens with undefined and null. Empty array gets cast to a empty string. Array with values gets cast to also a string where the values are separated by comma. Actually, when you apply to string method on any array with values, it's the same as if you would be calling join on it with comma as a argument, because that gives you the same outcome. The string of values separated by commas. And when you add empty string to an object, you get the string saying object. One notable exception to this is symbols, because since ES6 symbols are also part of JavaScript spec, its symbol is also a primitive value. So symbol can only be converted to a string explicitly. However, when you're trying to convert a symbol implicitly, like this, you will get a type error. All right. Conversion to a number implicitly happens in way more cases. Whenever you are performing one of the 5 basic arithmetic operations, exception is only with the plus, when one operand is a string. So then the previous case applies, which I showed. So when you have at least one operand a string, then the whole outcome will, also the other variable will be converted to a string. But in other cases, whenever you are adding 2 values, you're adding array to array or null to nan, JavaScript will try to convert them to a number first, and then we'll proceed from there. Same thing happens with comparison operators, greater than, lesser than, greater than equal, etc. With bitwise operators, with unary operator. Unary operator means that when you just add a plus in front of value, when you do, let's say, plus a string of 6, that string of 6 will be converted to a number 6. So That's unary operator. And also lose inequality operator. So when you're trying to compare two values of different types, first of all, JavaScript tries to convert them to numbers, and then proceed from there. Then that's the only way how JavaScript can answer the question, hey, are these two values equal? That it tries to convert them to numbers, and then then you give the answer. However, the exception to this rule is that when both sides are strings, then that the conversion doesn't happen. Also, of course, when both sides are let's say arrays or objects, also conversion doesn't happen, because this only happens when basically both sides are different types. So one side is different type than another. All right. So some examples with implicit conversion to number. With multiplication operator. So when you try to multiply 1 with this string, you might be maybe a bit confused why this is converted to 4,000. But in this case, this string neatly converts to number because this is scientific notation for 4,000. This means 4 times 10 to the power of 3. So that's why you get a neatly 4,000. Doing plus null will give you null. Giving you plus undefined will give you none. That's why doing null equals undefined, I mean double equal, not undefined, will give you false, because under the hood, JavaScript converts both them to numbered, tries to convert to numbers, and that outcome is not equal, so it gives you a false. Yeah, same thing happens with division, of course. This is pretty clear. When you apply this unary operator on a string, what JavaScript does under the hood, it actually trims the value. So it removes all the spaces between and after, and then tries to convert it. And in this case, it happens successfully, it becomes a 6. So in this case, let me see. This case, since, let me see, this one converts to a string. And with the white space removal, also tab and new line characters were also trimmed to convert to a number. However, I now forgot why this was exception and converted to a string. Let me see. This should be 6. Because of course, because here is an exception, because this actually is not a unary operator in this case. This is addition, and one of the operand is a string. So conversion, because actually then number 1 gets converted to a string, and you get a big string instead. Yeah, that's the gotcha in this case. And as a example of the rule that the coercion needs to be able to parse the string successfully. So in this case, yeah, it cannot do it. This doesn't make any sense as a number, so it becomes not a number. All right. Implicit conversion to Boolean happens in a lot less cases. These ones we know, of course, when you applying or, and, or negation operator. JavaScript needs to convert to a Boolean to learn the outcome. That I think most developers know pretty well and often use in their code to conditionally assign values to variables. However, as we all know, they only internally convert to a Boolean, but afterwards they return the original value. I will show you some code examples, and you will totally remember what I mean. And of course, under the hood, it also, when you do expression in if statement, it also has to convert to a Boolean to give you the outcome. But that I already mentioned. So yeah, what I meant with the code example before is that this well-known setup, right, with JavaScript before we get null sort of conditional optional traversal statement with the question mark and object, what you get now in TypeScript 3.7. So when with JavaScript, we're still forced to do this kind of thing, right? When you check if some variable is truthy, then you return it. However, if it's falsy, then you return a default value. Same thing with the end statement. For example, you do this chaining, right? You check that there options exist, that some property exists, and some deeper property exists. And if it doesn't, then you return another default value. I think these code examples everyone can recognize, and I think it's fairly known. But of course, under the hood, JavaScript must convert these values to Booleans first to know if it should proceed down the chain and which value it should return and assign to this variable. And of course, the negation operator converts whatever variable there is to a Boolean. In this case, it becomes inverse. So if it's a truthy variable, this one becomes false. And double negation is actually casting to a Boolean, because if this is truthy, first exclamation mark negates it, makes it false, and another one negates that false and makes it truthy. So if setting is anything truthy, then this will be true. There's a bit more sophisticated logic when you're dealing with objects. So I just wanted to mention it. I did not dive into that for this talk, so I will just briefly mention it. But yeah, there's a lot more under the hood, and another layer would be to look at an actual JavaScript spec, which is which may differ per engine. So I will not cover it that deeply. I just want to mention that with non-primitive values, when you're casting them like objects and arrays, it's not as straightforward in general. So there's a bit more logic into that. For example, only converting to a Boolean is straightforward. So all non-primitive values are truthy. So any function, object, array are truthy by default when you're trying to cast Boolean. I think that's very well known. However, converting to a string or number is actually done with a native to primitive method, which is implemented in native code in whichever JavaScript engine you happen to use. And then the logic is as follows: if the value that is returned from to primitive is already primitive, then just return it. First, try call to string. If that result is primitive value, then return it. However, if it's not, try value of. And if it's primitive, return that one. But if neither was primitive, then you throw a type error. So yeah, I have a couple more minutes. So I just want to show you a couple of interesting cases. So when you try to execute this line, you get a string plus a number plus a number. So here, everything converts to a string. So you get this nice string ABC12. However, when you change the order of operands, you get this outcome. And the reason is addition applies from left to right. So these first get combined. So you get a number 3, and then you combine this one, and then you get 3 ABC. And the rule was if one of the operands was a string, then everything gets converted to string. However, these two numbers were converted to a number first. That's an interesting case. Another one, I think I was circulating the Twitter sphere not long ago. I think a lot of people have seen it. So what's happening here? The reason for this outcome is that unary operator happens first, and unary operator is this one plus string A, and what it's trying to do is trying to convert this string to a number. However, A doesn't convert to a number, so it becomes a none, and the rest are strings, so that these are applied. This becomes a BA. BA tries to be added to none. None becomes also string, so you get BA none, and then you get another A, and the outcome is banana. So as I said, under the hood, when the types are different, double equality actually converts to a number. What it tries to do is try to convert both sides to numbers. So this one doesn't convert to number. This becomes none. This becomes 1. So because true converted to a number becomes 1. So that's why you get false. String true is not equal to just true. However, string 1 is equal to true. String 2 is not equal to true because 2 becomes 2 and true becomes 1 when converted to a number, and that is false. However, string 2 is equal to true plus true because these are converted to a number and they become 2, and this also becomes a number 2, and that is equal, so you get true here. Bizarre, right? Yeah, so another thing is that array within one number gets converted to that number. So you get this interesting outcome. So when you have one array, just do one item 5, and this string 5 also gets converted to a number 5, you get true. Actually, the same thing happens with if you have only one string inside an array and compare it to another string, it will also give you a true. Not sure if I included that in this slide now. And here, you might think, yeah, again, these should be tried convert to number, but no, that's what's happening. The coercion doesn't happen because it only takes place when both sides are of different type, and here all sides are objects. Even though when you're comparing array and object, type of array is also an object, so there is no type coercion happening. All right, yeah, that was it. So yeah, I think I made it pretty well on time. Let me see. I think I saw a question from Chris before. Yeah, is there a performance impact between implicit and let me show my face. Hope the stream and video will not be lagging too much. So if I know if there's performance impact between implicit and explicit conversion, no, actually I don't know. I haven't tested it out. That's actually a very good question. I think I'm curious to make actually a JSperf test to figure it out. I cannot really say. I cannot really say what might be faster. Oh yeah, that's 6 equals no. We're using triple equals 6. That is false. Oh no, sorry, no. Yeah, that plus 6. Yeah, because this plus 6 gets converted to number, and that is triple equals 6. Yeah, you're right. All right. What do I see? Another question? New comments. All right. I will give my give stage to Tim. So Tim, welcome. Come on stage. So
Hello.
Hey, welcome.
Hey, let me just try to click share on my screen.
Look at your screen.
Go.
And I will
Chrome tab.
will disappear. All right.
How's the sound? I just
Sounds perfect.
Yeah, we're good. Okay.
Yeah. Do you want your screen share to be full screen, or you want video cam to be on?
I would love my camera on.
All right. Cool. All right, guys. I'm disappearing. So take it away, Tim, and enjoy.
Okay, sounds good. That sounds nice because I have this fancy mic that I don't really use for this because I don't have my noise reduction and stuff like that, and my PC is making sounds. I'm gonna look how it. All right, we all look good. So today we're talking about JAMStack, right? And my talk is titled like JAMStack is the future. I think maybe. So let's talk about why. So first, I'll introduce then why should we change and use JAMStack, and then how JAMStack will actually fix stuff, hopefully. And then I have a demo for you, because why talk about something if you don't actually use it yourself? So I went full-fledged JAMStack into deep figuring stuff out. So I'll show you what I did, and then we're concluding, right? So introduction. Basically, everybody's talking about JAMStack now. And this is a presentation from end of 2019 when even more people spoke about it. We actually had conferences just about JAMStack. That was pretty cool, right? So basically this front end. I hope the sound works. That was me when I noticed that JAMStack was so cool and it was all front end focused and yeah, good stuff, right? So let's see. So this is again a slide from last year. Sorry, I should have updated it. But basically, JAMStack nowadays is like teenage sex. Everybody talks about it. nobody really knows how to do it, but everybody thinks everybody else is doing it. So everyone claims they're actually doing it. And this talk was more for JAMStack conferences, so then this slide would work because people would get upset because they all understand JAMStack. But actually there's just the simple jam we kind of get, right? But there's a lot more, and that's what makes this thing so interesting. So basically what JAMStack did, or what it actually started, is they created basically a new paradigm for application architectures. But why create a new one? Why do we need that? So let's go over what we have right now and why we should change, in my opinion, or change in certain circumstances, of course. So this is what most systems do. So they're an all-in-one package of goodness. So it has like all the front-end code base. It has a web server. It has application servers, CMS, digital asset management, product stuff, a bunch of databases, right? So we all know this. This is kind of, let's see, I hope you can actually see my mouse, but basically all the big players like Adobe AEM, Sitecore, Drupal, but also WordPress, from small to big size, they all did this monolithic approach. So I see, let me just have a look because there's so many comments. It's all Chris the Spider with his funny jokes. I love them, Chris. Keep them coming, please. So let's continue. So basically what you see, you have your user, and then there's this one big block that has web servers, CMS stuff, database stuff, all kind of together. And you see a lot of arrows because they're all constantly on and working together, right? So then I see with this a couple of issues. And actually there are a lot, like this cost, performance, security, power consumption, scalability, and state. So the bigger the scale of this, the more complex it is. Like I've worked, some of you know me, so you know I've worked on L'Oreal, where we built like over 800 websites all under one roof. And they were all based on this monolithical thing. And so the more scale you have, the more you have to orchestrate them together, and a lot of complicated stuff happens. So let's go dive into those a little bit, right? So costs. Basically, all these systems have 100% uptime, right? So they always keep state because they always talk to one another, because there is just one server here and one here and one here, all in one big box. It's on. This is expensive, power consumption, stuff like that. Even if you don't need it, it's still on. Then, yeah, Chris, just keep talking. It's cool. Sorry, I'm just looking at the comments once in a while. So security, right? If you have this much architecture that's always on, it's much easier to get hacked. There's much more surface area to actually try and mount an attack on. So if you think about it, actually Drupal and WordPress are the most hacked systems ever built. It's much better now, let's be honest. I have to be clear here. Right now it's cool, but over time it was pretty bad. So Alex, about the reduction in complexity, I'll get there. It's a very interesting subject. So power consumption. Like I said, they're always on, constantly draining power. Your carbon footprint is pretty high if you have all these servers there. Then we have scalability. What if Christmas traffic hits? How do you deal with that? So basically what you're going to have to do is have a company like Azure or whatever, some other company that deals with your stuff for you, pay them the big bucks to come up with all this scaling stuff. And if it goes wrong, to add another one, and being up at night and having tickets floating around and stuff like that. There's a whole bunch of extra stuff needed to happen. We did this for over 20 years. So wait, I'm just going to put my chat a little bit closer to my window because I keep putting my neck there. Okay, here we go. So for 20 years, and actually when I started research and I started thinking about that, I felt a bit like this little boy. It's kind of crazy, right? So we put our clients in this position because all these servers are freaking expensive. This is one of my favorite movies, I think. By the way, I think, yeah. So not everybody is this rich, right? Honestly, I have some clients that are, but if they are, let them pay for other stuff, like more storytelling related things, more creative stuff. There's no need for servers to be this expensive. So they are not that rich, but we make them pay like they are, right? So I would say, not in every case, but in a lot of cases, for a lot of websites from small to mid-level and even to some big level, JAMStack can come to the rescue. This is honestly my most fun hour of Photoshop I did in the last year. For the Frenchies under us, they will know exactly what this is, because when you go and buy some jam in the shop here in Paris, this is kind of what you buy, bon moment, and of course it's JAMStack. So JAMStack is coined by Matthias Bielmann, who's the CEO of Netlify, and it's a hard to read sentence. He likes to write all those things very compactly, but let's try. So, a modern web development architecture based on client-side JavaScript, reusable APIs, and pre-built markup. Basically, this still says a lot. It doesn't really narrow things down a lot, but let's go into it. So, I know a lot of you here are you probably just know already what the base is, because we've done this for a while, right? So I'll still go over it quickly, and then I'll show you my examples to see how much more complex it can get. So JavaScript. Any dynamic actions in the request and response cycle are done with JavaScript. So it's all on the client. There's no server side here. APIs. All the server-side processes and database actions and stuff like that are abstracted into reusable APIs that are generally small, and they're only accessed by JavaScript. And then we have markup, which is basically pre-built at deploy. So we're basically, again, building static websites like we used to do back in the day, right? Just HTML, CSS, and JavaScript. So this is an example of a super simple one. And I love Nuxt, so I decided to put that in there for this example. So what you get, let's see if you can see my mouse. Yeah, I think you can. So you're basically coding your JSON or some sort of data, markdown files, whatever you want. It can come from Visual Studio Code, or it can come from any sort of CMS that can write JSON for you. Then it goes into Nuxt, you build your lovely website, and then of course you commit. And then when you commit, in my example here, we have Netlify. And Netlify listens to that commit to a specific branch. And if that all works and it builds whatever, it actually runs a command for you. And in my case, Nuxt generate. Nuxt generate will output a static website for you. And then Netlify itself will deploy it on the Netlify CDN, on their own CDN, at the edge, which means let's say there's 30 locations. So your static website will now be placed on those 30 locations as close as possible to all the users. But what also means there's no central place, there's no origin. Your static files are just on all these surfaces, so it's completely distributed. If you want to do another update, you actually change your JSON file, you build your stuff, it looks good, you commit, and then Netlify again does a generate and puts it on the CDN. And then what you can see, the interaction of the user is literally only to the CDN. So this is, of course, a very simple version, right? We all kind of understand this one because Site and AWS Amplify, all these guys, they kind of do this. But then, okay, so the result was this fun stuff. I actually had a pretty easy job. Like, of course, I know my performance, I know my accessibility, so I'm a bit of a nerd for that stuff. But it was relatively easy to get this all to 100% with JAMStack, because the time to first byte is so low because it's just static stuff. And on top of that is that my website carbon is like super low. It's like 0.15 grams. And the average website as of end of 2019, I think, is like 4 grams. But if an average website has 10,000 views, I think there was a certain a calculation that it comes down to per year 500 kilograms of CO2 carbon emissions, which is insane. Like, there's no need for that. Just optimize your website. So JAMStack helps you to at least have a big chunk of that is good. Of course, you need to build a good website. Let's be honest. And then I started to realize, because I never used this kind of stuff. Like, I come from big business. I worked with things like Sitecore, all the big things, right? So I've always had to work in those monoliths, and was my whole way of working and thinking. And I always thought, okay, how do I put a nice front end on top of this monster, basically? And we've done well. If you understand the monster, you can do really good front end. But then I started to research this stuff and realize, hey, but now I have this static website. But not everything has to be static. There's like a whole bunch of like API third-party things that can also then attach to that website, and you can make it super rich if you want to. Let's talk about Algolia, for example, for search. That can just hook in and work. And there's a whole bunch of other stuff like Gigia for user accounts, Cloudinary for images. So there's a whole bunch of stuff that can go on top. I'm just getting some messages. Let me check. Okay, we're good. And then, so basically I had this moment of this. Everything opened up because you're no longer just a front-end dev. You're like expanding your horizons to much more. Like everything is like back-end and front-end are starting to come together, you know? So this is always a fun part of this talk because there's a lot of reasons why whatever you are building is actually not JAMStack, because everybody wants to say we did it in a JAMStack way, so it's modern and fancy. But actually, there's a lot of reasons when it's not. And I just want to go over them quickly. So when you use a server-side rendering CMS like WordPress or whatever out-of-the-box settings, then it's not JAMStack. When your single-page app actually has isomorphic rendering at runtime, so your SSR with Nuxt or Next in universal mode, and when you use a monolithic server run web application that uses like PHP or Java or whatever, and by showing you this doesn't mean that that is wrong. Actually, it's great. Like for a lot of our clients, we actually do partly that universal mode with SSR and stuff, and then partly static with JAMStack. So stuff that never really has to change can just be static. Stuff that's highly dynamic with products and stuff like that, you go into the isomorphic world, like Vue Storefront, for example, that works really well. So some of the benefits, I think a lot of those are quite clear already, but let's go over them. So I put those against the things that we talked about before, where we discussed like about the other systems that we have now, why they are not good. Let's go over those things and see how JAMStack can help. So it's clearly cheaper because there are no servers that are always on and talking together, right? Of course, this is the cost, not for the global picture, but just for you as, let's say, the web agency or the owner of this website. So you have not a lot. So I'm just looking at Dexter. SSR Next Sepper setup is not proper JAM certified. That is true, Dexter. I'm sorry. If you want to do JAM, it has to be static with JavaScript APIs. So if you do a pure single page app without the node part, it can be JAM again. So anyway, so if you look at the cost, there's no extra services on that have to be on all the time, right? It's going to be cheaper. Of course, there's other parts that make it way expensive. We'll get to that in a second. So security. If you have all those server-side processes abstracted into like smaller APIs far away that you only see at build or only use at build most of the time, there's just less points of access to hack, right? You're not going to hack a CDN with a static website. There's not much there unless you have like super bad JavaScript with like some issues that you can do cross-site scripting with. Of course, that exists, but generally it's harder to hack into. There's no /admin to hack into for WordPress, for example. I'm saying better. Alex, yes, this is true. If you execute that at build time and then output a static site, it's clearly JAM. This is true. In some cases, it's a better developer experience because there's no more CMS vendor logins. There's a super loose coupling between everything. So everything becomes little islands and you can just replace an island if you don't like it. Of course, that comes also with the burden of orchestration. So I'm not saying it's so much better, but for the end user, it's great because we can make super fast websites that progressively enhance and all of that stuff. Because if you don't have enough... Sepper export for the win. I'm going to have to Google Sepper. I'm sorry, I don't actually know it. Anyways, scaling. If your website is just a bunch of files, you can scale to the moon and back. You just add more CDNs. It's literally static files. That scales very easily, right? Actually, I think in this GIF, he's not happy but sad. I think it's my mistake. Anyways, it was meant to be happy. So actually, now it's time for the demo, because I spoke about all of this stuff, but I just love to dive in and actually use things and not go the simplest way, because that simple thing you can just read and understand, right? But I just wanted to show you a bit more bells and whistle, like, so I am a nerd, right? So that's why we're actually going to just dive in. So I'm just looking at Dexter. Oh, it's actually the Svelte app framework. Oh, thanks, man. I'm going to have to dive into that. Cool. So I actually chose to use Microsoft Azure as the base platform. And all my colleagues were like, dude, you have Netlify, you have Site, you have everything. But I work for Valtech, and they give me a Visual Studio Professional license, which is pretty cool because, well, sadly, Visual Studio is a 17 gigabyte turd. That's insane. I think it's not 17 gigabytes. My friends who are watching are going to be upset with me, but this is what every front-end dev feels like. The thing is, though, it comes with $140 a month Azure subscription, and I can use like everything Azure. And these guys are doing an amazing job, so I'm super happy I can actually use that stuff. So what I've built is something I call Strava Visualize. I wanted to do this because I might not look like it now, but I used to do a lot of sports, and I still ride my bike a lot. And I once ran a marathon, and I wanted to write some blog posts about the experience of running a 35K run and training, right? So what I wanted to do is embed my Strava activity. So Strava is a tracker like Nike Plus. So you can run with your phone or with a watch, and you can actually track your GPS and your time and your heart rate, a whole bunch of stuff. So I wanted to embed that nicely into my website. And if you embed Strava, it's a very sad experience. So what I wanted to do is actually show my run or my bike ride in real time in a super nice way. And what I decided to use is like, why don't I just build this? Because what I need is I have to look at the Strava API. I have a bunch of endpoints. I can do that with Lambda functions or Azure functions if you use Azure. And I used Cesium for rendering the world I'm running in. So anyways, let's just have a look. So of course, at a conference, you want to have internet. Now I have. So I'm going to actually share another tab. And I'm not sure, okay, so I'm going to have to share again. Bear with me. Okay, share. So now, guys, can you put back the, here we go. So basically this now is on Strava Visualize at webcore.windows.net. What basically is, right now I didn't turn on the CDN because it's too expensive. It's insane. But this is like the blob storage. Like this is an Amazon S3 basically. So what I built is something, okay, so you come and you want to visualize your Strava activity, right? So I'm just going to log in and say authorize. So now I'm doing an all-out flow. And this app is just a complete single page app right now. So what it did now is it went to Strava. It did an all-out, an exchange. I have a token. And then I asked the Strava API, give me all my rights. So this is March 12th, because now in Paris, oh, here we go. We cannot go outside. So this is from a while ago. So as you can see, this is my morning ride to work. So this is where I live. And then you can see in 3D where I'm going. And I just paused it here so you can have a look what I'm doing. You can see the globe here. I can zoom out and actually you see the world. So what this is, you can see the time, how long I'm on the bike, how far I am, my elevation, my speed. If I had a heart rate monitor on, you could see that too. You can see when I did it. And the cool thing about this is because this is in the morning, so the sun is in the morning and it's on the right place next to the globe. So it's just good fun to build this. And you can see the graph here, which is actually my elevation. And this is just a fun thing to look at and to build. And the whole point of this is now, I didn't finish it, to be honest, but actually this would have an embed button. So then I can just click embed, put it on my website in my blog, and actually there will be a little play button like a YouTube video, and it will play this for you so you can follow me. And I've also built that. Right now it's not in this version, but what I've built is you can see my peak heart rate, you can see the pictures I took. It's a good fun way, right? So let's now just go back and share my presentation again to show you actually what this is. Or you know what, why don't we just do one more run? Let's do it again, because it needs a whole bunch of cache. Like you see now that is a bit of jittering sometimes, and that's because it's loading so much data. I think local storage now has like 50 megabytes of images. But as you can see, Paris is not that hilly, but there's actually depth maps in here. Like if I had some runs that I did in Greece in the mountains, and you could actually see me running up and down, like super cool stuff. I didn't build a filtering of my activity, so I'm only showing the last 20 now. So it's not really finished. It's truly like just a way to show for the demo. So I'm going to go back to my other tab, share screen. There should be an easier way to do this. Anyways, it's fine. Am I getting back? Yeah. Okay. So basically, this is what we're looking at. So as you can see, this is now my central point that normally wouldn't be there if I used the CDN Edge, but it's just too expensive, so I didn't do that. Otherwise, I couldn't really use this to test out. But what this thing does, it's actually using Lambda functions, or in this case, Azure functions that are standing alone, right? So I need to do an authentication. So I authenticate. It gives me back a token. I store that locally. How I did that to be safe, that's not for this talk, but there was a bunch of stuff I had to do that with, like web tokens and stuff like that. So then for my activities list, I want this one. So I asked for that. And if for a certain user, I asked for the activities for, let's say, in the last couple of days, it actually caches that in here, which is a Redis cache. But it's also distributed, right? It's not a central cache. So they all have their own cache. And then I get back the activity when I click on a link, and then CSET-ML is actually a JSON structure for this mapping tool to be able to render the line properly. And there's a whole bunch of stuff that I had to do for that. And of course, GitHub, when I do a commit, this thing is just republished. And there's the Strava API. But I don't really hit the Strava API often because I have the cache. Okay, so I want to show you one more thing because I know I have 6 minutes left, so we're just going to go for it. So this is an application that I built for the Vue.js Amsterdam conference, which was now 4 or 5 weeks ago. So this is basically full-on JAMStack also, but I also added webhooks for some amazing extra stuff. So this is a pretty intense slide. But so let me just quickly go over what this is. And I'm in the process of actually making a YouTube video on how this whole thing actually works. Because what Fatty is a PWA that updates itself with webhooks, and it keeps me publicly accountable for my weight loss. So when I step on the scale in the morning, there's this, let me just look at Alex's question. Is the app build export running as Azure Functions too, or no? It's actually a separate service. You're right. There are ways, like when you use Netlify, to bundle everything up nicely with your functions, and like I have one whole app. With Azure, that's not possible. It's all decentralized. So I should have done it in Netlify, to be honest. Would have been much easier. So this thing is, so when I step at the scale in the morning, which is behind me actually in the room, it's connected to the internet. And then there's actually a third-party service called Withings that shows some stuff on my phone. And then it also has a webhook. So when I step on the scale, it shows a webhook. And that hook is basically a link that posts. Oh yeah, Dexter, you're right. You can actually use GitLab as well. Carwack, the visualization is actually using its Bing Maps API for the tiles, and it's using, I don't know the name exactly, but it's the same as the World Health Organization is using now for the population data with Corona. There's a whole bunch of extra data in there too that I'm using. And the tool to do the WebGL map, basically the world, is called CCM. I'll share those slides later for you guys so you can see. But basically, coming back to this, so a webhook is basically one service firing a link with a query parameter to another service. So in my case here, when I step on the scale, it automatically sends a link to my publish wait function, which is an Azure function that is basically always asleep until it's needed, and it just has one input, one output. But what this actually does, it's a little bit like Netlify CMS. I get that wait, I grab my JSON file with all the weights of my last couple of days, that basically then grabs that from GitHub. It does actually commit into the file, and like add an extra entry into the JSON, and then saves it and commits it to GitHub. But because GitHub gets this commit, there's actually Netlify, because Netlify waits for that commit to happen and then publishes my application with my wait. And then because it actually publishes successfully to the app, and that then of course goes to the Netlify CDN, because that's all the JAMStack part. There's also a webhook on success, and then the success actually tweets my progress. So which means this tweet function actually looks at the GitHub repo again to look at that list of JSON files, or one JSON file with my weights in it. So basically it grabs my last weight and my new weight, and it can do some calculations, and then it actually tweets stuff like this. So I lost 100 grams since the last time I weighed in 2 days ago. And for me, this is great, because when I want to lose weight, the people need to see that I do that, because otherwise I lose, I don't know, I'm weak. For me, I need public accountability. So that's a good, fun way to actually do a whole bunch of JAMStack-like things, server-like things, serverless-like things. It's super cool. So we have 2 minutes left, so I'm going for it. So the conclusion is, if you want to use JAMStack and a bit more, so the stuff I just showed you, you just need to learn what is the cloud, right? So I transcended from just being a front-end developer to being a web developer. And I urge everyone who watches this to do the same. Your world will just expand by so much. But I was basically like this when I was preparing this. Not now, because I did this like last year. And then this. And you can probably hear my dog in the background. It didn't stop. I was like insane. And then when I thought I did it, it was like this. And you know what? It's not that complex. But this is the thing. You basically have to become a cloud engineer. That's what makes it so hard. So what I've learned is we tend to use JAMStack to simplify our architecture. So we're grabbing back to one of the questions we just had in the beginning, right? We simplify things to make them smaller, less complex. We do that. But we take topics as smaller pieces, but then we have to realize we also have to orchestrate those things. We have to make sure everything works together. And it's really hard if you have a huge setup to actually put all those things in place and know they will just work together. It's a bunch of iteration that you need. So at least with a monolith, you have them all in one place, and you know when you turn them on, they kind of work. That's not always true, because I'm still, after 2 weeks, trying to install my Sidecar instance on my home PC, and it's still not there. So I'm not saying that is easy, but at least it's all in one place. So brain space is not free, right? So you kind of need to work on how it works with the smaller pieces now. So on the cloud side, so there's a lot for cheap. Like all of this I did, I hardly paid anything. But then when you want to use indexation for your search, or Elasticsearch or CDN, it's so expensive. So when you have to start to do real stuff, they bleed you dry. And the worst ever thing is the interfaces of those systems. Like please have proper UX designers to help you to create an interface for Azure or for AWS. Man, these things are so bad, and the documentation is never up to date because they keep on progressing. So when I started with those Azure functions, there were 3 versions out there, and I used one, and then the explanation was for the other one, and it never worked, and I was so upset until I understood. Then we're cool. Constant, you're right. Sidecar is never easy to install, but for us, we have Dockers, so it's kind of cool. And to do anything custom on the Jam with a bit more, you actually, like what I said, you have to become a cloud engineer. And suddenly there's so many extra things you don't realize, because actually, like if you have, let's say, one of those Lambda functions, you don't have all the dependencies you expect to have in a normal node environment, right? They might just only work as ASIC functions, or they don't, there's no file browsing, or like there's a whole bunch of stuff. But I use Docker. It still doesn't work. I'll come back to you. Because I know Bart is working at Sitecore using Docker. He's a fucking beast. He's awesome. So I'm going to have to talk to him, because his Dockers are like 3 gigabytes per Docker. And we have 5 of them. Anyway, I'm going to call you, Bart. So is JAMStack the future? I don't know. It will be part of it, right? The concept will clearly persist, but it won't be just this, because in this talk I already illustrated, I didn't just use JAMStack, because then it stops there. There's nothing extra dynamic. Like I work in e-commerce and do all these other things, personalization, all that stuff. That doesn't work anymore. So there are a whole bunch of other systems out there now, startups that are jumping onto this space to enrich this JAMStack thing. And you actually have companies now that make your Sitecore output into a JAMStack website, or your Adobe AEM. They put Next in front of it and they generate a static site. So there's all these extra things on top now, which makes it super cool. There's also companies like WeWeb, who, for example, go on top of WordPress and they create a graphical interface to edit your website. And then when you hit save, it actually outputs to a static website. This is clearly cool, because you can put it on all kinds of different CMSs, have your own components, and then output to static websites. So thanks for listening. I'm 3 minutes over time. I'm sorry. Oh, Bart is, I stepped on some toes here. He's going to explain some stuff to me. I like it. Guys and girls, thanks very much for listening this half an hour. I would love for you to go to my YouTube channel and subscribe, if you want, of course. I'm doing a whole bunch of interviews with web developers that are great in our community. I've done a bunch of those interviews also at the Vue.js Amsterdam conference. The next one about that is going to come out either tomorrow or Monday with Philip from Vue Storefront. But I'm also doing like this type of videos, like how does Webpack work, all this kind of stuff. But anyways, that's it.
Thank you, Tim.
You're very welcome, and I'm very happy I was able to speak here.
Yeah, it was amazing meetup. Everyone, thank you so much for tuning in. I think it was a great success. It was our first online meetup. I think
yeah, man.
In the third one. Just before we go offline, I want to give thanks to a man behind the scenes who also helped for this to happen, Puya from Passion People, one of Nuxt core team members. Thank you very much for helping this meetup proceed and happen. And yeah, everyone, thank you for tuning in, and have a nice evening. Good night.
I really love doing this. Like the day before, you text me, shall we do this? Okay, how do we stream? Oh, fuck. And now there you have it. Guys, this is awesome. It really is.
All right.
Technology for the win.
Yeah. All right. Good night and stay safe.
Okay. Thanks.